Now we will start today's video with the question 11. So the commutator frequency curves below show the average typing speed x words per minute of two groups of people A and B, and the number of people whose typing speeds are less than or equal to a words per minute. So along x-axis we have typing speed x words per minute, and along y-axis we have cumulative frequencies. Now in the part 1 we have to estimate the lower quartile, median and the upper quartile of group A. So for this, first we have to understand the scale along x-axis and y-axis. So scale along x-axis can be found out by subtracting the first 2 points scaled along x-axis, and those are 0 and 10. So 10 minus 0 divided by total number of square between these 2 points, and that is 10. So it will be equals to 10 over 10, and it will be equals to 1. So each square unit along x-axis is equals to 1. Now scale along y-axis. We have the first two scaled points along y-axis are 0 and 10. So 10 minus 0 divided by total number of square between these 2 points, and that is 10. So it will be equals to 10 divided by 10, and it will be gives us 1. So each squared unit along y-axis is also equals to 1. Since we know that the highest cumulative frequency is equals to the total number of frequency, so by using this fact, first we will locate the highest cumulative frequency from the curve. And since we know that the highest point on the curve for the group A corresponds to 40, so the total frequency for the group A is equals to 40. Now to estimate the lower quartile, for the cumulative frequency curve, we find the position of the lower quartile by using 40 over n over 4, and that will be equals to 40 over 4, and it will be equals to 10. Now an estimated value of the lower quartile can be found out by now we will look data values corresponding to the cumulative frequency of 10. So from 10 along y-axis we will draw a horizontal line until it touches the curve corresponding to group A. Now from the point of intersection on the cumulative frequency curve representing the group A, we draw a vertical line until it touches the x-axis. So here we have the horizontal line, the vertical line. Now since we know that each square unit along x-axis is equals to 1, so the value of the lower quartile q1 is equals to 21. Now to estimate the median from the cumulative frequency curve representing a group A, we find the position of the median by using n over 2. So here we have n divided by 2, and that will be equals to 40 over 2, and it will give us the cumulative frequency of 20. So now we will look data value corresponding to the cumulative frequency of 20. So from 20, we will draw a horizontal line until it touches the curve, cumulative frequency curve representing the group A. Now from the point of intersection on the curve, we will draw a, now from the point of intersection on the curve, we will draw a vertical line until it touches the x-axis. So from the graph we have the value 28. So the value of the estimated median from the curve is equals to 28. Now to estimate the upper quartile from the cumulative frequency curve representing group A, we find the position of the upper quartile by using 3 by 4n. Sorry, we have 3 by 4 multiplied by 40, and this will give us 10, and it will be equals to 30. So now we will look data values corresponding to the cumulative frequency of 30. So from 30 we will draw a horizontal line until it touches the cumulative frequency curve representing the group A. Now from the point of intersection on the curve we will draw a vertical line until it touches the x-axis, where we have the value, since each square not along x-axis is equals to 1, so we have 30, 31, 32, 33, and approximately 34. So the estimated value of the upper quartile Q3 from the graph is equals to 34. In the part 2, how many people are there in group B? To find the size of group B, we have to locate the highest point of the cumulative frequency curve representing the group B, which correspond to the cumulative frequency of 38. So from the graph, if we draw a horizontal line from the highest point of the curve representing the group B and extend it until it touches the y-axis, so the value here is approximately 38. So the number of people in group B, so the number of people in group B is equals to 38. Now in the part 3, estimate the interquartile range of group B. Since we have found out the total frequency for the group B in the part 2, and that was 38, so n will be equals to 38. Now to estimate the position of the lower quartile, we will use n over 4. So n over 4 will be equals to 38 over 4, and it will be equals to 9.5. Since we know that a square root along y-axis is equals to 1, so between 9 and 10, somewhere here, we have the value 9.5. No, from 9.5 we will draw a horizontal line until it touches the curve representing the group B. Now from the point of intersection on the curve representing the group B, we will draw a vertical line until it touches the x-axis. So we have the value 20. So the data value corresponding to the cumulative frequency of 9.5, we got 20. So the lower quartile Q1 for the group B is equals to 20. Now to estimate the position of the upper quartile from the cumulative frequency curve representing the group B, we will use 3 by 4n, and it will be equals to 3 by 4 multiplied by 38, since n is equals to 38. Now here we have 3 multiplied by 9.5, and it will be equals to 28.5. Now from the cumulative frequency curve representing the group B, between 28 and 29, somewhere here we have 28.5. So from 28.5 we will draw a horizontal line until it touches the curve representing the group B. Now from the point of intersection on the curve, we will draw a vertical line until it touches the x-axis. So from here we have the value lies between the points 28 and 29, so it is approximately equals to 28.5. So an estimated value of the upper quartile from the cumulative frequency curve representing the group B is equals to 28.5. Now to find out the estimated value of the interquartile range, we will use the formula Q3 minus Q1, and since Q3 minus Q1 are estimated from the cumulative frequency curve representing the group B, so the value of Q3 was 28.5 and the value of Q1 is 20, so it will be equals to 8.5. So the interquartile range for the group B is equals to 8.5, and this is an estimated value. In the part 4, we have to estimate the percentage of people in group B who can type faster than 38 words per minute. First we will find out the number of people in group B who can type less than or equals to 38 words per minute. Now from the x-axis we will locate the value 38, so where we have 38 somewhere here. Now from 38 we will draw a vertical line until it touches the curve representing the group B. Now from the point of intersection on the curve we will draw a vertical line, horizontal line until it touches the vertical axis. So here we have the value approximately 37. So the number of people in group B who can type less than or equals to 38 words per minute is equals to 37. Find out the number of people in the group B who can type faster than 38 words per minute. We can find out this by subtracting the number of people in the group B who can type less than or equal to 38 words per minute from the total number of people in the group B. So we have 38 minus 37 and we will get 1. Now to find out the percentage of people in group B who can type faster than 38 words per minute, we can find out this percentage by using the formula of percentages. So here we have the number of people in the group B who can type faster than 38 words per minute is equals to 1, and divided by total number of people in group B, and that is 33, multiplied by 100%. Now after simplifications, we will get 2.63%. So 2.63% people in group B can type faster than 38 words per minute. In the part 5, do you agree with the statement that the people in the group A generally type faster and have a more consistent typing speed? Justify. So first we have to find out the interquartile range for the group A. So here we have the formula Q3 minus Q1. So for group A, the Q3 was 34 and Q1 was 21, and it will gives us 13. So interquartile range for group A is equals to 13, and the interquartile range for the group B we have find out in the part 3, and that was 8.5. So the answer to this question is no, since the median typing speed of group A is higher than group B. The people in group A generally type faster than group B. However, the interquartile range for group A is higher than group B, which means the group A is less consistent than group B. And the question 12, 800 people were surveyed on their average waiting times at a polyclinic on a weekday and on a weekends respectively. The cumulative frequency curves show the waiting times x minutes and the number of people who waited for less than x minutes. So along x-axis we have waiting time x minutes, and along y-axis we have cumulative frequencies. Now in the part A, we have to estimate the interquartile range of the waiting times on a weekday. First, we have to understand the scale along x-axis and y-axis. So for scale along x-axis, we have the value 10 minus 0 divided by the total number of square between these 2 points, and that is 5. So it will gives us 10 divided by 2, and it will be equals to 5. 10 divided by 5, and it will be equals to 10. So each square unit along x-axis is equals to 2. Now scale along y-axis. We have 2 points. 100 minus 0 and divided it by the total number of square between these 2 points, and that is 5. So 100 divided by 5 is equals to 20. So each square unit along y-axis is equals to 20. Now in the part A, we have to estimate the interquartile range of the waiting time on a weekday. So first we have to find out the lower quartile and the upper quartile from the cumulative frequency curves for the weekday. So to estimate the position of the lower quartile from the cumulative frequency curve representing the weekday, we will use n over 4, and since n total frequency is equals to 800 people, so 800 divided by 4 will gives us the cumulative frequency of 200. So now we will look the data value corresponding to the cumulative frequency of 200. From 200 we will draw a horizontal line until it touches the curve representing the cumulative frequency curve weekday. Now from the point of intersection on the curve we will draw a horizontal vertical line until it touches the x-axis. So here we have the value lies between somewhere 28 and 29. So it is approximately, since we know that each square unit along x-axis is equal to 2, so we have 22, 24, 26 and 28. So between 26 and 28 we have the value 27 approximately. So the lower estimated value of the lower quartile q1 from the cumulative frequency curve representing the weekday is equals to 27. Now we can estimate the position of the upper quartile by using 3 by 4n. So here we have 3 by 4 multiplied by 800, and after simplification it becomes 200, and it will be equals to 600. So from 600 along y-axis we will look the data value for the corresponding to the cumulative frequency of 600, and we will draw a horizontal line until it touches the curve representing the weekday. And from the point of intersection on the curve we will draw a vertical line until it touches the horizontal axis, where we have the value after 50 we have 52. So here the value is 52. So the upper quartile estimated value of the upper quartile q3 from the cumulative frequency curve representing the weekday is equals to 52. Since we have estimated the values of the upper quartile and lower quartile from the graph, so we can find out the interquartile range, estimated value of the interquartile range by using the formula q3 minus q1. So the estimated values of q3 and q1 are 52 and 27 respectively. So 52 minus 27 will gives us 25. So the interquartile range of the waiting times on weekday is equals to 25 minutes. Now in the part B, estimate the number of people who waited for at least 64 minutes on a weekday. So from the graph, the number of people who waited for less than equals to 64 minutes. So now we will look the data value corresponding to the cumulative frequency corresponding to the waiting time. Now we will look the cumulative frequency corresponding to the data value along x-axis. So for 64 here we have 62, here we have somewhere 64 here. So from 64 we will draw a vertical line until it touches the curve representing the weekend. Now from the point of intersection on the curve we will draw a horizontal line until it touches the y-axis. So here we have the cumulative frequency corresponding to 64 is equals to 600. So now the number of people who waited for less than equals to 64 minutes is equals to 600. Now to find out the number of people who waited for at least 64 minutes is equals to, or can be find out by subtracting the number of people who waited for less than or equals to 64 minutes from the total number of people. So the total number of people is 800 minus, since we have find out the value of the number of people who waited for less than equals to 64 minutes, and that was 600. So 800 minus 600 gives us 200. So the number of people who waited for at least 64 minutes is equals to 200. David visited the polyclinic on a weekday and waited for 36 minutes. Estimate his waiting time if he were to visit on a weekend. Now from the weekday curve, the number of people who waited less than 34 minutes is equals to, for this we will less than 36 minutes, not 34. So here we have to locate 36 along x-axis. So along the x-axis we have 36 here. Now from 36 we will draw a vertical line until it touches the weekday curve. Now from the point of intersection on the weekday curve we will draw a horizontal line until it touches the y-axis. So here we have the value 330, 320, 340. So the number of people who waited for less than 36 minutes is equals to 340. Now from the weekend curve, from 340 we will extend the horizontal line until it touches the weekend curve. Now from the point of intersection on the weekend curve we will draw a vertical line until it touches the x-axis. Right, we have the value corresponding value 52. So from the weekend curve 340 people waited for less than 52 minutes. So David would have waited for 52 minutes if he were to visit on a weekend. Now, in the part D, part 1, are the waiting times shorter on a weekday or on a weekend? Justify your answer. To justify our answer, first we have to find out the median waiting time for the weekday and median waiting time for the weekend. So to find out the position of the median, we will use n over 2. So n over 2 will be equals to 800 divided by 2, since the total frequency in this case is 800, and 800 over 2 will gives us 400. So now from 400 we will draw a horizontal line until it touches the curve representing the weekday. So here we have the value 40 minutes for the weekday, and we will extend this horizontal line until it touches the curve representing the weekend. Now from the point of intersection on the commuter frequency curve representing the weekend, we will draw a horizontal vertical line until it touches the x-axis. So here we have the value after 50, 52, 54, 56. Between 54 and 56, here we have the value approximately 55. So the value of the median waiting time for weekday is equals to 40 minutes, and median for weekend is equals to 52 minutes. It is approximately 55, not 52. 55 minutes. So the answer is weekday, because the median waiting time for the of 40 minutes on a weekday is shorter than the waiting time of 55 minutes on a weekend. So our answer is waiting times are shorter on weekdays. In the part D2, do you agree with the statement that the waiting times on a weekend are more longer and more consistent? Justify your answer. So the answer is yes. The median waiting time is longer on a weekend. The median waiting time is longer on a weekend. Now we will find out the interquartile range for the waiting time on a weekend. So first we have to find out the estimated position of the lower quartile by using n by 4, and here we have 800 divided by 4, and it will be equals to 200. So from 200 we will draw a horizontal line until it touches the curve representing the weekend. Now from the point of intersection on the curve, we will draw a vertical line until it touches the horizontal axis. So here we have the 42. So the estimated value of the lower quartile Q1 from the cumulative frequency curve is equals to 42. Now to find out the estimated value of the upper quartile, we'll use 3 by 4n. So it will be equal to 3 by 4 multiplied by 800, and it will gives us 600. So now we will draw a horizontal line until it touches the curve representing the weekend. Now from the point of intersection on the curve, we will draw a vertical line until it touches the x-axis. So from here we have the value approximately 64. So the estimated value of the upper quartile Q3 from the curve representing the weekend is equals to 64. For the value of the interquartile range, we will use formula Q3 minus Q1. So the estimated values of Q3 minus Q1 are 64 minus 42, and it will be equals to 22 minutes. So in the interquartile range of the waiting time on a weekend is 22 minutes, which is lower than that on a weekday, indicating a smaller spread and hence more consistent waiting time.